Thank you for joining us for today's webinar, A Practitioner's Guide to Meeting ENERGY STAR 3.0 Heating, Ventilation, and Air Conditioning Systems Contractor Checklist Part A. Today's webinar is part of a series to assist rural organizations comply with ENERGY STAR 3.0 requirements. During today's webinar, we will be reviewing the national program requirements which define core energy efficiency specifications, including air conditioning, Contractors of America CCA, Manuals J, S, and D, and HVAC System Contractor Checklists. I'd like to introduce today's speaker, Gene Gonzalez. Gene has been working in rural affordable housing for over 30 years. Over the course of his career, he has gained expertise in property management, green housing, rehabilitation, and affordable housing. Gene has extensive experience including subdivision, development, single-family housing rehabilitation, Section 202 housing, and Sections 514, 516 farm labor projects. For the past 4 years, Gene has provided training and technical assistance in green building, energy conservation, home rating, and green rehabilitation for single and multifamily projects. Gene's knowledge of construction has allowed him to teach groups new smart construction along with passive solar, straw bale, and Adobe. Welcome, Gene.
All right, well, thank you everyone for joining us. Like Stephanie said, this is part 3 of a 4-part series for ENERGY STAR. Hopefully we can at least get you some knowledge of some of these requirements that are needed to meet ENERGY STAR. Sometimes it's very difficult to meet ENERGY STAR depending on what part of the country you're in, but hopefully this presentation will help and assist you in understanding the formulas that go into picking a furnace, heating, air conditioning for your particular unit in your particular area. The heating and cooling system, it's one of the first requirements that you need to do in the house. Like the picture says in this one, a cozy home requires a good comfort system. A good comfort system begins with a professional design. Before we get into the checklist, there's certain things that we need to complete and things that we need to look at. In order to reach the formulas and everything that you need to do to calculate the loads, the calculations, the equipment that you're going to need for your unit, and the duct design, you need to get into the certain manuals and tells you how to design these things. Again, when we're talking about the heating, ventilation, and air conditioning systems, any plumber or installer that's going to be used to certify your unit ENERGY STAR has to be certified by ENERGY STAR. Again, there's a list on ENERGY STAR's website that you can get a list of all the certified plumbers and installers for ENERGY STAR ratings and certification. And then I just put the definition for the ACCA. It's Air Conditioning Contractors of America. Again, we'll be referring to that acronym a lot as we go through the PowerPoint. The first thing you're going to look at is you want to design the calculation load of how much heat you need to heat that unit, how much cooling systems you're going to need to cool that unit down. The Manual J load calculation, this is a booklet that is given to you most of the time. In most states like Colorado, Wyoming, western states, I'm not sure about back east, but what they'll do is when you go in to pull your permit, your building permit, they'll ask you if you're going to put in a new furnace or you have an existing furnace, and they'll give you a copy of the Manual J calculation load manual. And they'll also, then they'll describe that to you, they'll explain it to you, and they'll make sure that you understand that you have to do these calculations before you even finish pulling your permit. The Manual J, this is the first step in designing your heating system or your air conditioning system for your unit. Again, the designers, they're going to have to be certified. Most of the time they're architects, engineers that are certified in heating and cooling designs. They're going to determine the amount of heat that is lost through the exterior of the building and the amount of heat that is gained through the exterior of the building during the warmer months. Again, you're going to analyze all aspects of the thermal characteristics of that building, and we'll talk a little bit more about this as we get into it. But you're actually going to be looking at all the walls, you're going to be looking at all the floors, the ceilings, all the doors and windows. You're going to be measuring all the openings, you're going to be measuring all the windows, all this stuff is going to go into the calculation of your manual J. So this is just the beginning of it. You're looking at the process. He's doing the calculation of how much of the solar heat gain you're going to get during the summer, how much heat loss is going to go through those walls during the winter. Again, the heat calculation load, it takes into various factors. We're going to talk about the home's geographic location. Where are you on the planet Earth? And then on the planet Earth, where are you in the United States? Or what part of the country you're in. That part of the country is going to make a big difference on the equipment that you choose and the selection and the type of materials that you're going to be building with. So again, it makes a big difference on the geographic location, everything from your HERS rating test all the way to the construction and the materials that you'll be using, all your energy efficiency material that we talked about in the last two webinars come into play. Again, the orientation of the sun, which direction does the house face? Again, does it face south? Does it face north? Where does the sun come up on that building? Where does it go down? The envelope tightness, hopefully by now you've done all your construction on your unit. It's all tight. We talked about envelope tightness, everything that you had to do, caulking, seal plates, etc., insulation, so on. Duct leakage, we'll talk a little bit about duct leakage again, but we talked about that in the last webinar, how you want to make sure that all your ducts are airtight. They got the mastic at every joint. There's no air leakages. There's no crinks or bends in your ducts. And then we talked about light and appliances, all your Energy Star lights, appliances, those type of things. So all that is taken into consideration when you're coming up with this load calculation. Again, it also is going to calculate how much heat and humidity each occupant of that house is going to need to heat up that occupant or to keep him cool. So again, it takes into consideration everybody that lives in that unit, the bedroom size that they're going to be in, all those little sweaty kids in the back. They're going to be able to determine how much heat and how much cooling they need to keep those kids warm or cool, depending on the conditions outside. Again, there's two ways of doing your manual J calculation. One of them is you're doing a whole house block calculation, and the other one is a room by room. And we'll talk about each one in the next slide. A whole house ventilation or a whole house load calculation. This is basically used, let's say you're doing acquisition, rehab, resale, and you're trying to bring these units into code. Sometimes you don't have to redo the duct system, and you're just replacing the furnace. So on this one, on those kind of units, you would be using a whole house system. It cools, it provides the heating and cooling loads for the entire unit. You're not just talking about a room by room. You're talking about the whole house as a whole. So what does it take to heat that whole house, cool that whole house? So you're thinking of it as a whole house unit. You're not looking at it room by room, and we'll talk about the room by room next. Again, you can use this whole house when you have an existing duct and all you're doing is installing a new furnace and you're not doing any major modifications to the heating system other than putting in a new furnace. Again, you wanted to use this whole house to determine the equipment size. Again, we'll talk about equipment size later on, but this manual J is going to tell you the size of a furnace, boiler, heat pump, whatever it is that you're going to be installing into that unit, the size that you will need to make that unit comfortable heating and cooling wise. And again, the matchup is required in placing the heating system into an existing home. Again, back in the day, I'm sure everybody has seen those old gas furnaces they used to be old coal furnaces, and then they converted them to gas, and they've got this big old furnace down in the basement, and it looks like there's octopus arms coming out of these furnaces. Well, all those furnaces were modified back in the day, and nobody did a manual J on there, so they just left those big 10-inch heat ducts, and they put in a gas furnace with the same ducts. So the rooms on the far end of the house were always cold because the ducts were too big, and there's too much air in there to try to heat to get that hot air towards the end of the unit. So again, you're matching your heating system to your duct system, okay, with your men. The next one is a room-by-room load calculation. This is basically used on new construction. Anytime you're doing new construction, depending on each individual room within the house. You don't need you're not going to need the same duct size to each room in the house. The same duct size that goes into the living room, you may not need for the library or for a little den that you have in the back. So you can determine the room size individually. If you only need a 6-inch duct going to the back room, where you might need a 10-inch duct going into the living room, those are going to determine the sizes of the ducts by the size of the room and the heat load that you need for that particular room. Again, it determines the amount of air that you need for each individual room. It's going to be whether the room, depending on the size of the room and what the room is used for sleeping, a bathroom, whatever it may be, it determines that size of ducting and air system or ventilation that you need for that unit, for that particular room. Again, this is critical because you want to determine the duct system and the duct size to meet your furnace system. Again, if your furnace system doesn't meet your duct size, you're going to get complaints like, oh, the back room's always cold, no matter how high you have the thermostat. So, you got to make sure that your duct system matches your furnace and so on. And we'll talk about different types of furnaces as we go along. But again, this is critical in determining your duct size and your heating loads because you need to determine your furnace size and your duct size. And this is just the two processes. The next manual we talk about is the Manual S, or Manual Selection. It's the equipment selection. So once you've done your Manual J is going to tell you what size of furnace you need, what size of cooling equipment you need, whatever it is that you may need to heat that unit up comfortably for that family. And this is just what the Manual S looks like. Again, once the Manual J is done and is completed, the heating design and the information required by the Manual J is going to tell you the equipment that you're going to need, the size of the equipment that you're going to need, to the total capacity to remove any kind of heat or moisture from that unit, and then what is the pressure of that system can produce. One of the things you need to take into consideration when you're talking these units, sometimes a single service unit runs in half tons. So if you got a 1.5 ton unit up there, it's probably just a single speed. If you have a 2 ton, 3 ton, 1 ton, those kind of tonnage, you're going to have a 2-speed switch. So just remember that when you're doing that, because it'll ask you that in your checklist a little bit later on. Again, what's the pressure of a system? We talk about the systems, and sometimes you talk about heat pumps or whatever, the 3-ton. Remember, a 3-ton system up in Maryland is not going to work as the same as a 3-ton system in Houston, where there's a lot of humidity and the temperature difference range. So again, you have to take all this into consideration when you're picking your equipment. I just put a new pump on my house. I put a 3-ton. It works great, And then after you do both of those, now you're going to do your Manual D. The Manual D is you're designing your ducts, and this is measuring the ducts, and you talk about your layout of ducts throughout the unit. Okay, and again, this is the ACC. This is the way you determine the duct layout, including all the individual duct sizes. We explained the various duct sizes that you might need. You don't need a 10-inch duct going into that small den in the back. You might get by with just a 4 or a 6-inch. Again, you need to do the 4. Either you completed the room by room, or you completed the house, whole house Manual J on these. Again, we talked about, in the good old days, 6-inch vent is 8-inch duct, that's fine. So you can't go with that anymore because of all the new equipment that has come in. The rule of thumb, it just doesn't work anymore. So now you have to do these calculations in order to make sure that these furnaces are working properly, they're getting the right airflow, the right pressure in these ducts, and it keeps the house at the right pressure. Since we're building these houses energy efficient and we're building them real tight, and pretty much anything below 70, our HERS rating of 70, 65, 50, I've seen them as low as 42, almost close to net zero units. So very careful on what kind of equipment you're installing and so on. Again, we talked about this a little bit earlier. Some of the complaints you're going to get if your duct system doesn't meet your furnace system is you're going to get complaints of temperatures. You know, some rooms are hot, some rooms are cold. The house, you know, just doesn't stay warm. Complaints of excessive noises. Noises, we're talking noises from the furnace. Ducts may rattle, furnaces may rattle, things like this. So, you know, if you got old equipment and you're not doing these manual J's on them, you might run into trouble, and you're not doing the families any favors. Okay, so finally we get to the checklist. This is a checklist. Again, it should have been provided to you in the very beginning. I think Stephanie also provided it now as an attachment, but this is the checklist that we'll be talking about and basically going through. Again, this is the contractor's checklist. Once this checklist is completed, it goes to the HERS rater. The HERS rater will come back and verify everything on this checklist is completed and is verified. One of the things that you need to remember with the checklist is that this is required in order to get any kind of rating or any kind of system in this. Again, it depends on who's going to rate the checklist and who's going to fill it out. The checklist can be filled out either by the contractor or by the builder. Again, as we go down the checklist, you're not going to get every part of this in the units that you're building. If you're building a unit and you're putting in a forced air furnace, or if you're putting in a heat pump, you're only going to deal with those sections of the checklist and then some of the sections at the very bottom of the checklist. Again, you're not going to be filling out all the checklists. You're only going to be filling out the checklist that relates to your particular unit. Again, who fills out the checklist? Again, it says who's going to fill out the checklist. The builder can verify most of the stuff until it gets into the testing of the equipment. After that, the builder can verify that, and either the credential, contractor, or constructor has to verify anything like that. Or if a HERS rater is hired, he can do that also. But if you have a HERS rater rating these things up front, it can't be the same HERS rater coming back to verify what the HERS rater is rating at this particular time. So there again, it's better to have the contractor verify it, have the rater come back and verify it. So you're not having to deal with two raters. Okay, so this is the checklist. It's 2 pages. It comes with some points and some instructions in the back, but they're not very helpful. It's basically, one of the things you need to remember is that you're not going to be filling out this checklist. It's going to be the contractor, or it's going to be the builder, or it's going to be the heating and cooling installing guy. So again, this is just a formality so you can understand what they're doing, what it is that they're looking at. So when you get the report or you're reviewing the report before it goes to the rater, you might have some questions, or you can see that there's a section that's missing, or there's something that isn't attached, because it calls for a lot of attachments. Everything that they verify, any kind of equipment they install, it says you need to verify and you need to attach all the specifications of that equipment installed. Okay, I think I'm getting ahead of myself, but again, depending on who signs the equipment, it's either going to be the builder or it's going to be the contractor. The contractor's checklist is broken into various parts. We got the whole mechanical ventilation system, heating, cooling, all these different sections. Again, you're not going to hit every one, depending on the kind of construction and the heating systems that you're putting in. You know, these are the things that you'll be looking at. Again, once you get to furnace selection, the builder verifier, or the verification by the builder, ends here. He can only verify up to the furnace selection. After that, it either has to be a contractor verification, or it has to be a HERS rater who's coming in to verify all these tests. So the first thing on the checklist is you're going to have a whole building mechanical ventilation design. So by this time you've done your manual J, you're meeting your ASHER 2010 requirement, and then you're taking into systems. Okay, what kind of system are you designing? Is it going to be restricted to outdoor, indoor? Is it going to be continuous operation, ventilation? So again, we talked about this part down here where it says documentation is attached with ventilation system type, location, and design rate. So anytime a system they're putting in, if they're putting in a forced air furnace, they need to have all the specifications, the system type, location, and the design rate attached to that. So we talked about this in the very beginning when we were doing the checklist, and we're doing these checklists and we're putting these manuals together. You're going to have 3 manuals. One is going to go to the builder, one is going to go to the homeowner, and one is going to go to you as the organization if you keep track of your units that way. So you should have a binder for every unit that you build. Everything that is given to the homeowner, you should have a copy. The contractor should have a copy. So if there's ever any questions, you just pull out the manual and everybody can be on the same page of what was going on. Again, with the document, with the continuous operating vent and exhaust, since we're building our houses so tight, and let's say you're coming in, your HERS rating units are coming in at, let's say, 50 or 65 or 50 or better in tightness, you're going to have some kind of ventilation or an exhaust system or somehow to bringing in fresh air into that unit because your unit is now too tight. So again, you're going to have some kind of exhaust system in there. And is it going to be a continuous operating vent and exhaust system, or is it going to be a system that just works, at least once per day, or is it going to be a system that runs 10% every 24 hours? So depending on the tightness of the house, depending on the equipment, depending on that need for fresh air to be brought into that unit, that is going to determine the type of equipment and the size of the equipment that you're going to be putting in for continuous air or ventilation. If your units are coming in at a HERS rating of 70 just to meet Energy Star, you probably don't have to bring in fresh air or fresh air into the unit. It should be tight enough and it should be breathing enough to where it's okay. But once you get into the HERS ratings of 50 and lower, that's when you need to start taking into consideration this air exchange. One of the reasons, especially in the Southwest and a lot of areas, you get a lot of the radon gas or a lot of radon that gets built up into these houses. And if they're real tight and there's no fresh air coming in or moving air out of that unit, that radon can stay trapped inside that house and create other problems. So again, depending on the type of the unit will determine the type of exhaust and ventilation systems that you need. Again, I know this is very complicated, but again, it's something that you're not going to be doing. But if you see a HERS rating unit, a HERS rated unit come in at 50, it's going to be something that you're going to want to know, okay, what kind of ventilation system does that have? How does it run? How often does it run? Make you look real smart when you're talking to contractors and builders. Again, so now we're talking about the heating and cooling design. This is number 2 on your checklist. This is where it gets into a lot of stuff. Like I said, you're not going to be doing this. The contractor's going to be doing this, or whoever your person is doing this. But you want to be able to understand how these things are determined and how they come to be about. Okay, so with the heating and cooling system 2.1, it's going to talk about how did you come to this measurement. The heat loss and the gain method. So in this particular case, we probably use the manual J. So all you're going to do is you're going to check the manual J, and who's checking it? It's either going to be the builder or the contractor for now. Again, the duct design, how did you determine the duct size, the duct design? Again, you probably went with the manual D. Again, you just check manual D on your checklist and you move on down. Equipment selection, how did you come to the selection of your equipment? Again, you probably want to check the manual S because you did the manual S to select the equipment needed to match the requirements to keep the conditions of that house comfortable. So again, these are just tests that you're going to be doing. Then it talks about heating equipment, outdoor design temperatures, where's the location. This is where you talk about location. People can, you can either say wherever you're located, and then it'll talk about the efficiencies of the units. Okay, and then it's going to talk about the orientation of the rated house. Again, which is the orientation? Does it face north, south, east, west? so on. Again, it's very important, when we talked about the orientation of these units, you want to set them, as many of them. If you're doing a subdivision or if you're doing units, you want to try to set as many facing south and southeast as possible. Not all of it, you're not going to be able to do that for all of them. So again, some of the equipment and some of the HERS rating that you're going to get are going to be a little bit different because of the orientation. Again, then it takes into the number of occupants served by the system. You're going to have to count everybody that's going to stay there, including the student that's away at college and is only there maybe 3-4 months out of the year, but you want to count them. It talks about the conditioned home and the rated unit. Again, we're talking square footage of the conditioned area or of the heated space only. Again, we're not talking garages, basements, unconditioned basements, anything like that, just the conditioned area. We'll be talking about window areas. You're going to want to measure every window. The way you measure those windows, it's going to be from the top to the bottom, left to right, width. Again, remember when you're doing windows and you're measuring windows, you want to make sure that the windows match or meet egress. Again, egress, is considered, you got to have at least 24 inches minimum opening height and 20 inches wide. 20 inches high and 20 inches wide for that window to meet egress. So in order for somebody to be able to crawl out of that window, and they can't be disturbed with anything else. Again, you need to remember the number of bedrooms or the number of occupants. The way they match occupants is that there should be 1 occupant per bedroom, plus 1. So if you got a 4-bedroom house, you're going to have 5 people that occupy that house, more or less. So that's how they match it up. And then again, for a HERS rater, anything that can be used that is 70 feet or larger and can be used as a sleeping area, such as a den or something like that, or library, if it can be used as a sleeping area, it can be counted as a bedroom. Okay? The window area, we talked about the window area. And the predominant window solar gain, this is just something that, you take all the windows, you measure all the windows, you combine the square footage of all those windows, and then you figure out the solar gain. And this is the predominant window solar gain. And this is all this is it just takes the measurements of all the glass, all the sun that hits the glass, and that gives you that calculation. Okay? Infiltration rate, the infiltration rate is just your blower door. It's talking about your blower door. It measures the infiltration rate or your heat loss or your air infiltration into that unit. Okay, that's all that is. The heat gain and the sensible and latent heat gain, these are all off of your furnaces and your cooling system. Same thing with your design heat gain, heat loss. These are all things that are going to be on your furnace or on your furnace specifications. What's left? Oh, the design airflow, again, all this is included. The design heat gain, let me go back there to the design heat, latent heat gain, and your total heat gain. These are all measured in BTUs. For those of you who don't know what a BTU is a British thermal unit. It's equal to 1 wooden match if it burned from tip to tip. So the energy and the heat that one match puts out is 1 BTU, okay? So when you talk about a furnace with 85,000 BTUs, it talks about it's a furnace that is burning like 85,000 matches at one time. So that's just how the British thermal unit is determined. Remember, it's just 1 wooden match and what the energy and heat that match produces. The mechanical ventilation rate, that's cubic feet per minute. Once you get your fan and you're putting these fans in, it'll tell you how many cubic feet per minute that fan will move in air, okay? And those type of things. The design duct static pressure, this isn't a water column, but it's nothing that you're going to be able to measure. It's just something that the contractor will be able to do. And then again, it talks about the full load calculation report. So when you've done your manual J, your manual S, and all this other stuff, all those need to be attached to this report or to this checklist for your rater to review and to make sure that it meets the specifications and everything else that is in the design. Okay. So now we're on number 3. It says selected cooling equipment. Again, you're not going to be doing all these things in your units, depending on where part of the country you're in. In the Southwest, we usually just put forced air heating units and evaporative coolers. Heat pumps are making a big come in now. I mean, people are starting to use heat pumps. Again, we'll talk a little bit about heat pumps a little bit later on. But again, cooling equipment, if you're going with the refrigerated air or you're putting something in the walls, a lot of places you'll see now is they put these little heat cooling units in the walls and they run with sensors. As you walk into the room, the cooling unit will go on. If somebody walks out and there's no activity in the room, the cooling unit will go off. Same thing with heating and cooling units. So they're on a sensor now, and the only time they come on is when somebody's in that room or there's some kind of activity in that room, which I think is great. But anyway, the cooling condenser is, again, you're going to have to list your manufacturer and your model number in there. You got your heating, cooling, manufacturer model, the fan coil, also if it's an evaporator and a heating cooling unit, depending what it may be. It's going to talk about the reference number, and it's going to list your efficiency. For electric coolers and heating, they're going to talk about HER, EERs, and CERs, SEERs. And this is just a rating system, an electrical rating system of what the output of that unit will be. The bigger the SEER is, the more the unit's going to be able to produce and heating and cooling. The metering devices, these are all different types. Like I said, if you're not using these, you're not going to be familiar with them. But they have an expansion, a thermal expansion valve, a fixed orifice. All these things are on your equipment, depending on what the Manual J calls for in the equipment selection. Again, all this stuff will be stated in that equipment and what you need to do. Again, the systems and the different kinds of systems, the listed system, you need to have one that's at least the value or the design. It can't be less than the 3.8. Heat gain has to be a value of 2.2 or greater. Again, at the very end, this has to be an AHRI certification attached. So anything that all this went through in the inspections, the installation, the equipment, the design, everything that's on there has to be certified, and you have to have this certification attached. Again, not many people are using cooling equipment. A lot more, I think, are looking at heat pumps. Again, heat pumps, there's not much to these. Again, the only thing you want to do with heat pumps is you want to make sure that the heat pump is going to work for you in your area. New Mexico right now is, like I said, heat pumps are starting to come into our area. But before you buy a heat pump, is it the best choice for you? Is it something that you can use in your area? One of the things with a heat pump is if the temperature drops below 45, let me see, I got to rethink that. If the temperature rarely drops below 40 degrees, you can probably heat your house with a heat pump. If it drops more than 40 degrees, then you probably want to have a heat pump, and you're going to have some kind of backup system with this because of the temperature drop outside. So the heat pump will work. Let's say, if it drops up to 40 degrees, you're good. If it drops below that, then you might want to have a backup system, either gas, electric. I have a heat pump. My backup system is an electric furnace because I live out in the country. We don't have gas out there, so the only thing I have is electric. So I put this heat pump in to help me heat and cool during the summer and the winter. But during the winter, we might get maybe 2 weeks where the temperature drops 25, 30 degrees, and that's our winter. That's as cold as it's going to get. So our heat pump works great, except for those 2 weeks when it really gets cold. Again, is the heat pump your best choice? You might, is the Manual J, once you look at your Manual J and you do your Manual S and your Manual D and all this stuff, it might say, a heat pump isn't going to be the best choice for you. It might be a split system. It might be a furnace with evaporative cooling, with another cooling system. So who knows? It all depends on what your Manual J determines for your area. Like I say, New Mexico is a great area for heat pumps because it rarely gets below freezing, especially down south. Again, depending on what size and how much your unit is, it'll tell you. The unit, you want to make sure that it performs well at 17 degrees Fahrenheit. This is at the test when it's going to be at its coldest, and then at 47 degrees Fahrenheit. Okay? There's not much to heat pumps. It's just simply the testing and the installation, and that's it. Okay, and the next thing is your furnace. This is going to be number 5 on your checklist. Again, your Manual J probably told you, okay, you're going to need a 225,000 BTU forced air furnace, 85 efficiency. So you're going to put in here, okay, the model number, the furnace, whether it's the Therm or Eureka, whatever the furnace type might be, and then you're going to put the model number. Also, when you get your furnace and you buy the furnace, it's going to come with this little pamphlet, and it's going to tell you what the energy efficiency is. As of 2015, all energy efficient furnaces or any furnaces that are going to be sold have to meet the minimum of an 80% AFUE. And the AFUE stands for Annual Fuel Utilization Efficiency. So what that means is basically when you buy a furnace, and the furnace has to be a minimum of 80% efficiency or at its utilization efficiency. So if you, as of September 2015, all furnaces sold in the United States must meet at least 80% minimum of energy efficiency. Mobile homes, 80%, oil-fired furnaces, 82%, gas boilers, 84%, and oil-fired burnt boilers, 83%. So you see where these have increased a lot. In the past, from 1992 to present, they were at 75% AFUs. So they actually increased them about probably 7 or 10% efficiency on all the furnaces across the board. So again, you want to remember when you're buying equipment, and if somebody's trying to sell you a furnace that is only at 80% or at 75% efficiency, that's not going to meet your requirement. Again, just be familiar, because some of the furnaces out there that they're selling are still old furnaces and may not meet this requirement as of 2015. Okay, so again, it's going to list the efficiency as when you bought it. It'll say, 85, 91. Once you get into the 90s, 90% efficiency and up to 95, those are what they call your high energy efficient furnaces. These are going to take special installers. You have to have a contractor that's licensed both in gas and in electric, okay? And you're going to have both of these coming in. Gas, you need to have a plumber and an electrician, in order to install these units, because the high energy efficient furnaces are going to take a lot more gas. They burn the gas a lot higher, and they produce a lot of condensation, which you're going to have a drip pan at the bottom to catch all this condensation. Either you need to have a drip pan, or you're going to have a line that goes directly into a drain system, so that condensation from that heating equipment can actually drain and isn't causing any damage anywhere sitting there, because it's going to be water sitting somewhere if you don't deal with it directly. Again, you're going to be talking about the output of the heating capacity of valve of 5.3. All furnaces and all heating equipment have to work between 100% to 140% of design. So, again, if your heating and cooling system comes in and it's at 225, they say it's 85% efficiency. You come in and you test the efficiency, and you find out it's only at 80%. Okay? So there again, you're going to have to look at that furnace, or also have the contractor look at it, because it's either too small or it needs to be some kind of modification brought up to the 85% efficiency. Okay, so that's pretty much it on your furnaces. Again, your Manual J is going to tell you the size that you need, and then you're just going to list all the efficiencies, the make, the model, and so on. Again, this is going to go into your binder. Okay, so after this is as far as the builder can verify or the builder's representative can verify. After this, because of all the required refrigerant tests, it can only be verified either by the contractor or the credential contractor or your HERS rater. Again, if you're using a HERS rater to rate these parts, then that same HERS rater can't rate the overall unit. So again, I would use the contractor to verify these, use your HERS rater to come back and verify all this stuff. In the next PowerPoint, the next session, we'll talk about the HERS rater's checklist. But for now, we're just dealing with the contractor's checklist. Okay, so the refrigeration test, again, depending on the kind of systems you're putting in, you want the ambient temperature at the condenser. You're running all these tests. Well, you're not running them, but the installers or the HERS rater is going to be running this. The liquid line pressure, all this stuff is just stuff that they're going to be testing with the refrigerated air condensers. That's pretty much it. There's not much I can explain here. Like I said, most of this is going to be done by your contractor, your installer. They're going to rate it and note it. Again, for calculations, this is what we talked about, that thermal expansion valve. These are usually units that are the ton units. They usually have a dual system. They have a subcooling valve, but they also have what they call a dual system. They either have a high and low switch and so on. So they have the subcooling valve. All these things are checked, okay? Again, with the system with the fixed orifice, this is usually your half-ton equipment. They only come with one system. I mean, one speed. It's usually just one speed, that's all. Pretty much it's going to be the same thing. You got the overheated system, the OEM. But again, these are all just calculations that are going to be done once a system is installed, and it has to be done by a certified refrigerant contractor. Not too many people that I know are using refrigerant heating and cooling, maybe in your area, but like, you know, what I see most of all is I'm starting to see a lot of heat pumps, but I mostly see forced air furnaces with some kind of cooling system. Again, electrical measures, these are just for evaporative furnaces. This is your fan in your furnace, your evaporative cooler, not your evaporative cooler, your your cooling systems, and so on. So it talks about your condenser unit. It'll talk about the air handler fan, the size, the speed, those type of things, okay? So it's going to ask you, you're going to perform a test, and it's going to say, oh, wait a minute, I'm wrong. Yeah, so you're going to talk about the condenser unit, the ampage. Again, this is all going to measure in ampage, 240s, 140s, whatever the ampage may be to that unit. Most of them are going to be 240 because they're big units. If you do window units, those will probably be a 120, but 110. But again, depending on the system you're using, the equipment, the size, that'll depend on the ampage. Line voltage, again, the line voltage talks about whether it's going to have a separate line coming just to that equipment or a separate line, or it can be plugged into something that's already there. I just put in these new hot water heater on demands in my house. My house is all electric because we live out in the country, and I put these hot water heater on demands, but I found out that you had to run whole new wires and double 80 amps into these things. So I mean, by the time I ended up running these new wires, double amps, putting this thing in, it cost me about $1,000. But my water bill my electric hot water bill went down from $178 to $72 a month. And that was because I had this giant 80-gallon hot water heater that was running on electricity all the time. Big difference. But again, you have to look at the equipment, what is it you're installing, and what it is that you're going to need. Airflow test. Airflow test, you know, this is just the airflow test that you're talking about. We're talking about the air that comes out of your heating and cooling system, the duct air static pressure, the supply duct pressure. Again, you're going to be testing all your ducts. You drill a little hole, you put your little monitor in there, and it'll tell you the pressure into that into that duct. It'll tell you the airflow through there, and it'll tell you the the static pressure that you got going through there. Again, depending on the static pressure in your duct system, that is going to determine the size of filter and the type of filter you need to put into your heating system. You might have to put in a type of filter. I forget what it is. I think it's a V6 or an MEX6 filter. What that does is that cuts all the dust, pollutants out of the air, and it keeps all the dust from getting back into your system. You need to make sure that your test holes are able to locate, and they're easily marked, because the contractor or the rater has to come back and rate and see that you actually tested these, and they might want to test them again just to see if your readings or your HERS rater's readings are the same as your contractors. Again, your airflow volume at your evaporator, that's something that, you know, is part of the test. Air balance, again, we talked about air balance. This is going to have to be room by room. The air design, you want to balance these out. Sometimes you'll need a jump vent. We call it a jump vent. You put a little vent on top of above the door, just to keep the air pressure and the temperature inside the house. Again, your contractor is going to be using the ACC and the manual for that. Measure documents, again, it's going to be verified by your rater per item. That's why I say if you can get the builder to verify most of this, your rater, you only have to have him once, or one rater. And the last thing, remember we talked about those high energy efficient furnaces. What happens with those is they have that drip, that condensation moisture at the bottom of those things. So you got to have a drain pan for those, and you either got to have a corrosion resistant drain pan or a properly slowed drain system where it drains into a sewer, into a drain system. And, you know, because remember, like I explained, the heating and cooling component is going to produce condensation because it's burning the gas so hot and so fast that it creates condensation. And that's the moisture that comes and builds up under those furnaces. So anytime you're installing a high energy efficient furnace, 90% or better, you need to make sure that you have this drain pan and that drain system in there. All right, that's it for this one. Hopefully I didn't confuse you. It helps a little bit just to kind of understand. Remember, you're not the one that's going to be doing all these things, but you're the one that may be reviewing them, and you're also definitely going to be wanting talking to your contractor, your HERS rater, about the equipment and how that's being determined. And like I say, the good old days of rule of thumb and all that looks good. Can't do it that way anymore, folks. But any questions? Hopefully, you know, if you have questions, you can call me anytime, and I'll try to help you through them. Here's some of the reference materials that we have. It's good to look at some of these. Again, the energy codes for rural development and HUD have changed. They've gone to the new energy codes, so just keep that in mind. And I think that's it for this time.
Thank you, Gene. That was wonderful. I don't see any questions in the chat box. I'm going to turn off lecture mode here for just a moment. If anyone would like to ask Gene any questions, now is a great opportunity. But like he said, his contact information was in the presentation. It's on HAC's website, so please feel free to reach out to Gene directly after the webinar as well. Does anyone have any questions? Okay, so we'll move forward. Just a quick reminder before we wrap up today, the recording and all the materials will be available on HAC's website. Please also be on a lookout for an email containing links for your certificate of participation and an evaluation for today's webinar. I'd like to thank Gene for the wealth of information he provided during today's webinar, and thank you all for joining us for today. Please enjoy the rest of your afternoon, and thank you so much. Goodbye.